Hello everyone, welcome to the channel. So we are going to start a new series for class 10 student who are going to appear for their board examination this session. A series that will be covering all the important questions from syllabus of class 10. From each and every chapter we'll be covering the some most important questions. So let's begin series with real numbers. So first of all, let me give you a brief weightage or marks distribution for this chapter. This chapter is of total 6 marks in your board examination. So this 6 marks are distributed. This marks distribution is as per the sample paper released by CBSE. So out of this 6 marks, you will have 1 mark question as assertion and reasoning question. Then there will be 1 question for 2 marks which have internal choices in it. Here optional means internal choices. Then you will have 1 3 marks question in which there are no choices. You have to attempt it. So in total 6 marks this chapter will be covering. So this video lecture will be for now divided into 2 parts. In first part, we'll be solving all the important questions related to proof, which means in the questions we need to prove something. First, we'll be covering that. In the second part of the lecture, we'll solve some different type of questions related to this chapter, which are very important for our board examination. So let's begin. Our first question is a PYQ question from paper CBSE paper of 2018, which is a 2 marker question, and it is given that if root 2 is a irrational number, we need to prove that 5 plus root 2 is an irrational number. So as I've mentioned, we will be first covering the proof question. So let's solve it. We need to prove these values need to be proved, and it is already given that this root 2 is an irrational number. So first of all, let's assume this number as a rational number. So you know that all the rational numbers are in form of p by q. So we'll be equating this value as p by q. Now if we further solve it, 2 root 2 p upon q minus 5. If I took the LCM here, is equals to 2 root 2. Now if I simplify the root 2 here, I'll get root 2 is equals to p minus 5q upon 2q. This is the value which is equals to this. The value p minus 5q upon 2q is equals to root 2. And as we know, or we could say, already mentioned in the question, that root 2 is an irrational number. This value is irrational number and this value is equals to root 2. So from these two reference, we could say that on comparing this statement and the equation we got, we could say that 5 plus 2 root 2 is an irrational number. Okay, so now let's begin with question number 2. The next questions that will be covering this proof part here is the question number 2 and the question number 3. These type of questions are very frequently seen repeated in CBSE board examination. This one is for 2019 for a 2 mark question. These two were for 2019 as 2 mark questions, and similar type of questions have also been seen in the sample paper of this year, as well as these type of questions come under important questions for this chapter. So we'll be solving these two questions also with the same method. We have solved first one. So let's begin with the solution. So for the question number 1, it is given that, we have to prove 3 plus root 2 as an irrational number. Okay, so again we will consider, let's consider this number as rational number. So this number will be equal to P by Q form, and we'll now take this 3 on the right hand side, P by Q minus 3. If we took the LCM, we'll got P minus 3Q upon Q, which is equals to root 2. And as we know here, now in this question it is not given us. So question number 4 says add as find the multiplication of HCF to LCM for the numbers as 100 and 190. It is a 2-mark PYQ for year 2018. So let's solve question number 4. For this question, we'll be using the property as HCF of A and B into LCM of A and B is equal to product of A and B. So we have given in the question, as per the question. For the question, we have given value of A as 100 and value of B as 190, and we need to find the multiplication of HCF and LCM of A and B. So we can use this identity and find it. So simply HCF of 100 and 190 into LCM of 100 and 190 is equals to 100 into 190, which is equals to 19,000. That is the answer for question number 5. Now let's solve question number 5. Question number 5 says that two numbers are in ratio 2:3. If their LCM is, it is given. The ratio of two numbers is, this is the ratio of two numbers, and it is given that their LCM is 180. We need to find the HCF. Let me consider the HCF as X. So as you people know that on solving the ratio part, we need to take the values as, so these two number will be taking as 2x and 3x, as these are the co-prime, the pair of co-prime numbers. They should be, they are the factor of some number, so we are taking x part with it. So as we know that, so these 2x into 3x, it will be equals to 180. Okay, as they are the as their HCF will be 1, we are using the same property we have used here, that LCM cross HCF is equals to A and B. We are given that LCM is true as these number are co-prime numbers, so their HCF will be 1. So now on solving this, 180 is equals to 6x, so x is equals to 30. Now we will find the actual two numbers. So that was 2x, which is equals to 2 into 30, 60. The next is 3x, that is equals to 3 into 30, that is 90. So now the actual two numbers are 60 and 90. Now we'll put these number in the in our formula, that is HCF of A and B into LCM of A and B is equals to A dot B. So we have to find the HCF of A and B, and it is given that LCM is 180. We got to know that one number is 60 and the other is 90. On solving it, we got HCF as 30 for these two number. So our last question for this video is again a proof type of question, which says as prove root 3 as an irrational number. So it is more of a theoretical question. So I have already written the explanation part of it. So it will be very easy for you. And if you use the same explanation part and the same method in your board examination, you will be guaranteed be getting full marks in this question. So the question says as prove root 3 as an irrational number. So in previous question we were given that root 3 is an irrational number, or for assumption we have referred that we know that root 3 is an irrational number, but this question says us to prove root 3 as an irrational number. So what we'll do, will first of all assume again, as per the previous questions, we'll assume root 3 as an rational number. So the property of rational number says that root 3 equals to p by q, where q should not be equals to 0 and p and q are co-prime numbers. Okay, p and q are co-prime numbers. Then we will square both the sides. On both the sides, LHS and RHS. So we got, in place of root 3 into root 3 is 3, which is equals to p square upon q square. So p square is equals to 3q square. When we shift this denominator q square on the LHS, we got p square is equals to q square. So from this equation, this one, we can say that 3 is a factor of p square. And if 3 is a factor of p square, it also should be a factor of p. Getting the point? If I tell you, if p square is, if p is 4, something, so let this value assume as our q and this as p. So p is a factor of 2 now. Here we can get say that p is a factor of 2. With the same explanation, I could say that p square is a, if we could see from this equation, if I square on both the sides, so 4 square into 2 into 2 to the 4. Again I could say if this is p and this is q, so p is a factor of 2. Again I could say this. So from this explanation, I assume here as p square is a factor, sorry, 3 is a factor of p square. So we could also say that it is also a factor of p. Now as it is a factor of p, I assume p is equals to 3m. M could be any natural number from 1 to infinity. So p is a factor of 3. As p is a factor of 3, we have already proved it. Now again, we took this equation, this, let's name it as equation 1. From equation 1, we have written as p square is equals to 3q square. Now we'll substitute this value of 3m is equals to p. So 3m whole square is equals to 3q square. Okay, on solving it, on solving the square value, we got 3m square is equals to 3q square. On solving is 3 ones are 3 and 3 threes are 9. We got 3m square is equals to q square. So from the same explanation, I could say that 3 is a factor of q square and also 3 is a factor of q. Now here's the point. This these two these two set of statements, set 1 and set 2, are contradict to our assumption that p and q, 3 root 3 is equals to p and q, where p and q are co-prime numbers, for which I have given the explanation here in the bottom. P and Q have at least 3 as a common factor. We have proved it that here is also P is a factor of 3 and Q is a factor of 3, which contradicts the fact that P and Q have no common factor. They are co-prime numbers, which contradict our fact, our assumption. So our assumption is wrong. From this, we have proved that this assumption, which says that root 3 is equals to P by Q, where P and Q are co-prime number, is wrong. And as root 3 is not a rational number, root 3 is not a rational number, from this we could say that as this assumption is wrong. So if root 3 is not a rational number, it will probably an irrational number. So root 3 is an irrational number. I hope you got this question. And in place of root 3, we can also see questions that prove root 2 as an irrational number, at the same time root 5 as an irrational number, and that could also be solved with the same methodology. If you want the video on that also, you can comment me and we'll surely prepare a video for that as well. This was a part till now. This was the part for important questions of real number, chapter number 1 of class 10th. We'll be continuing further chapters in the next video. So thank you so much for watching.